Hey everyone, welcome back to the channel. Before we dive into today's eye-opening topic, let me take a moment to send some positive vibes your way. To all of you watching right now, wherever you are in the world, I truly hope you're feeling healthy, happy, and full of energy. May your days be filled with good health and wonderful moments. Now, get ready to learn something astonishing about our bovine friends. A single cow can produce up to 100 kilograms of methane per year. That's right, those gentle grass-munching animals we often see in fields are actually walking methane factories, and this has huge implications for our planet's climate. Let's explore why cows produce so much of this potent greenhouse gas, how it affects our environment, and what scientists are doing to address this utterly surprising climate challenge. When you picture a cow, you probably imagine it peacefully grazing in a field, chewing its cud, and generally being one of the most harmless creatures on Earth. What you might not realize is that every time that cow burps, yes, burps, not farts as commonly believed, it's releasing methane into the atmosphere. Methane is a greenhouse gas that's about 28 times more effective at trapping heat in our atmosphere than carbon dioxide over a 100-year period. An average dairy cow can produce between 70 to 120 kilograms of methane annually, while beef cattle typically produce 40 to 80 kilograms. That means just one cow's annual methane output has the same warming potential as burning about 1,000 liters of gasoline. Multiply that by the roughly 1.5 billion cattle worldwide, and you start to understand why livestock contributes about 14.5% of all human-caused greenhouse gas emissions globally. It's not the cow's fault, of course. This methane production is a natural byproduct of their unique digestive system that's evolved over thousands of years to break down tough plant materials. The reason cows produce so much methane comes down to their specialized stomachs. Cows are ruminants, meaning they have a four-chambered stomach designed to ferment tough plant fibers that most animals can't digest. The largest chamber, called the rumen, is essentially a giant fermentation vat filled with billions of microbes that break down cellulose from grass and other plants. These microbes produce various gases as byproducts, including carbon dioxide, hydrogen, and methane. The cow periodically regurgitates and reaches its food, that's the cud chewing you see, to further break it down, and all this microbial activity generates significant amounts of gas that must be released. An average cow belches out about 250 to 500 liters of methane every single day. Imagine filling up several large beach balls with methane gas daily from just one animal. The methane is produced as part of normal digestion and represents a loss of about 2 to 12% of the energy the cow consumes from its food, which is why farmers actually have an economic incentive to reduce methane production. It means more energy from feed goes into making milk or meat rather than being lost as gas. What makes cattle methane particularly concerning for climate change is its potency and the sheer scale of global livestock production. While methane doesn't stay in the atmosphere as long as carbon dioxide, about 12 years compared to centuries for CO2, it's much more effective at trapping heat during that time. Scientists estimate that livestock methane accounts for about one-third of human-caused methane emissions worldwide. As developing countries increase their meat and dairy consumption to match Western diets, the global cattle population continues growing, potentially increasing these emissions further. The good news is that because methane is relatively short-lived in the atmosphere, reducing cattle methane emissions could have a rapid cooling effect on global temperatures, making it one of the most promising short-term climate solutions available to us today. Researchers around the world are working on innovative solutions to reduce cattle methane production without harming the animals or dramatically changing farming practices. One promising approach involves modifying cow diets to include feed additives that change the rumen environment. Adding small amounts of seaweed, particularly a red seaweed called Asparagopsis taxiformis, to cattle feed has shown methane reductions of up to 80% in some studies because compounds in the seaweed inhibit the methane-producing microbes. Other additives like garlic extract, essential oils, or nitrate supplements also show potential. Another strategy involves breeding low-methane cattle. Scientists have discovered that some cows naturally produce less methane than others, and these traits can be selected for in breeding programs. There's even research into vaccines that could target methane-producing microbes in the cow's gut, preventing them from generating the gas without affecting digestion. Farmers are also experimenting with different management practices that can reduce methane emissions while often improving animal health and productivity. More intensive rotational grazing systems, where cows are moved frequently to fresh pasture, can lead to healthier grasslands that store more carbon in the soil to offset some methane emissions. Providing higher quality forage and balanced diets helps cows digest their food more efficiently, producing less methane per liter of milk or kilogram of meat. Some dairy farms are installing methane digesters that capture manure emissions and convert them into renewable biogas that can generate electricity, turning a climate problem into an energy solution. These practical approaches show that reducing cattle methane doesn't require eliminating livestock farming altogether, but rather making thoughtful improvements to existing systems. The cattle methane issue also raises important questions about how we balance environmental concerns with global nutrition needs. Livestock provide high-quality protein and essential nutrients to billions of people worldwide, particularly in developing countries where alternatives may be scarce or expensive. Cattle also play important cultural and economic roles in many societies, and for smallholder farmers, they may serve as living savings accounts and sources of fertilizer and draft power. Completely eliminating animal agriculture isn't a practical or equitable solution for everyone. However, in wealthier nations where meat and dairy consumption is high, reducing intake of these products, especially beef, could significantly lower methane emissions while often improving human health. The emerging field of alternative proteins, including plant-based meats and lab-grown meat, offers additional pathways to maintain protein supplies while decreasing environmental impacts. What's fascinating is that cattle methane production is actually part of a natural carbon cycle that existed long before humans domesticated animals. Wild ruminants like bison, antelope, and deer also produce methane, but their populations were kept in check by predators and limited food supplies. The climate impact comes from humans having dramatically increased cattle numbers far beyond what would exist naturally. There are now more cattle on Earth than at any point in history. This highlights how human activities can take natural biological processes and scale them up to the point where they disrupt Earth's systems. The solution isn't to villainize cows, but to find ways to bring their methane production back into balance with what the atmosphere can handle, whether through technological innovations, dietary changes, or smarter farming practices. Looking ahead, addressing cattle methane will be an important piece of the climate change puzzle. While carbon dioxide from fossil fuels remains the primary driver of long-term climate change, methane reductions can help slow warming in the near term while we work to decarbonize our energy systems. Some experts estimate that global implementation of available methane reduction strategies could cut cattle emissions by 20 to 30% in the coming decades. When combined with reductions from oil and gas operations and landfills, other major methane sources, this could help buy valuable time to address the more challenging CO2 emissions. International agreements like the Global Methane Pledge, which aims to cut human-caused methane emissions 30% by 2030, are starting to recognize livestock's role in methane mitigation alongside fossil fuel and waste sectors. The story of cattle methane is ultimately one about interconnectedness, how human food choices affect microscopic gut bacteria, which affect atmospheric chemistry, which affects global climate patterns. It shows how solving environmental challenges often requires understanding complex biological systems and finding solutions that work for both people and the planet. As research continues and new technologies emerge, there's real hope that we can maintain livestock farming while dramatically reducing its climate impact. The next time you see a cow contentedly chewing its cud, remember there's a lot more going on inside that stomach than meets the eye. And that scientists around the world are working to ensure cattle can continue providing food for humanity without overheating our shared home. Thanks for joining me to explore this fascinating climate science topic. Stay curious, stay engaged, and I'll see you in the next adventure.